What I'd like to do over the next few minutes here with a couple of different functions is explore some of the big ideas that we are really aiming at, such as finding solutions, sketching our graphs, finding with rational functions, finding horizontal and vertical asymptotes, as well as the solutions. Now, if you are here thinking about a project, your Chapter 5 project, dealing with creating some functions with certain characteristics, then hopefully, ideally, this will allow you to tie some of those concepts together. And if you use this video right, you might actually be able to use what I do here to reverse engineer, to work backwards to what your function might look like based on the characteristics that we discuss in this video. So to begin with, I want you to notice that these are both going to be written factored. This first one is written in the factored form. I'm perfectly fine with that because that allows me to see my solutions very easily. Now you can multiply this out, okay, double distributing and whatnot. You can do that, there's no problem there. But I want to notice that because there are two x's, there are two x terms in this function, we have two x terms, this is a quadratic. Right, so this is a quadratic. It has a degree of 2, okay, is the way to think about that. A degree of 2. Now that gives us a basic idea. It's going to look like a parabola. Now, because it has a leading coefficient here of -2, that's a stretched, reflected parabola. All right, so I'm going to just go ahead and sketch this. So if I want to know what the solutions are, I can look at what makes each of these terms 0. So for the first, x equals 3 will be a solution. For the second, x equals 4 will be a solution. If I plug those in, that will make it 0. So I've got a 0.3, a 0.4. Now this is a reflected stretched parabola, so I'm going to have something that looks like this. That's the basic idea of what it's going to look like. Reflected, so it faces down, it opens down. The quadratic, so the end behavior, it works in that idea, it's in that parabola shape. And the two solutions from those factors there. All right? So we can form a pretty good sketch just from that, and we can recognize characteristics going from our equation to our graph. Those two tie together. All right, so for my next function, I want to look at a rational function. G of x equals 2 times x minus 3 times x minus 4, all over 3 times x minus 3 squared. All right, so one thing I want to observe first is a vertical asymptote. This is a rational function, okay, because I have a ratio of two functions. And my vertical asymptote occurs where the denominator is 0. The denominator here will be 0 when x equals 3. My function is undefined at x equals 3. So when it comes to my sketch here, all right, here's 3. I'm going to have a vertical asymptote there. Okay. Now, my horizontal asymptote, I can also determine that. That is going to be y equals, and this actually depends on the degrees of the polynomials. Okay, so first, in our numerator, we have an x squared. And notice it's very similar to the one we had previously. Hint, hint for your project. The numerator is a something x squared. It's quadratic. The denominator is also a quadratic. Oops, I wrote a cube there. The denominator is also quadratic. So the horizontal asymptote is a ratio. It's the ratio of these leading coefficients. So the leading coefficients there would be 2/3. So the y equals 2/3 is our horizontal asymptote. So let me go ahead and put a point right here. There's 1, so there's 2/3. There's what my graph's going to begin to look like. All right, now, next I have my solutions. Okay, my solutions are going to be, my solutions will happen where the numerator is 0. So the numerator is 0 at x equals 3 and x equals 4. Now, you should observe that we actually have a vertical asymptote at x equals 3. So there's not actually a solution there. There's just a solution at x equals 4. So right here at 4. All right. So my function is going to approach that line. So what I'm going to do is I want to make a table. Let's pick some points. Let's take x equal to 5. Okay. Well, that would be, we'll have a positive denominator, positive, positive. It's going to be a positive. All right, now that will be, let me grab my calculator real quick. If I plug that in, all right, 2 x minus 3, x minus 4, divided by 3 times x minus 3 squared. Okay. And if I go to my table, at x equals 5, let's go over there, that is 1/3. All right, so a point that I have is 5 1/3. So it looks like my function is going to be below that. And if I do look at a graph of that, that's what it's going to look like. It is going to approach that right there. Now, the vertical asymptote, it cannot touch that. It'll approach it, but it can't touch that. So it'll be down there. Let's pick another point. Let's say x equals something less than 3. How about 0? If x is 0, that is 8/9, or 0.8 repeating. So 0 and 8/9, that is above that point right there. Let's pick another point. How about -2? No, actually, let's go with +1 first. At 1, we have 1. All right, 1, 1. So we've got a point right here. We know we're going to approach this asymptote, this vertical asymptote. And because it's approaching 2/3 as a horizontal asymptote, we know that it's going to do something like that. Now, there could be some twists and turns. The function can actually go back and forth and cross a couple of times. But the idea is it's going to approach that. So now if we want a good graph, use Desmos.com, use a TI calculator, do something like that. But for a sketch, I can look at that. So again, going back to our project, if we know what we want the horizontal and the vertical asymptotes to be, you can maybe see how you can work backwards to the function from those characteristics that we've got displayed right here. And again, I'll point out these two functions are very similar. Okay, one is reflected, one is not. That's one important thing. So pay attention to these characteristics and see if you can come up with a function that matches all those characteristics. All right, good luck.